Happy Monday or Tuesday to everyone. It's Mrs. Coleman here. Today we are going to go through section 7.4 notes, solving polynomial equations in factored form. So the whole point of this is how can you solve a polynomial equation? Up to this point, we've worked on various ways of adding them together, subtracting, and multiplying. Now we're getting to the part where we're actually finding the solutions. This is what a lot of you guys have been wondering and wanting to do. Whether or not you truly want to do it or not, that's what you've been hinting at as you work through these. So before we get to the actual notes portion, we are going to go through some vocabulary terms that are going to be extremely important as we move forward. So we're going to flip down to page 221 in your student journals. And that's where we're going to go over just a few terms. So the first one, factored form. So a factored form is a polynomial that is written as a product of factors. Next, we have the zero product property. So the zero product property is if the product of two real numbers is zero, then at least one of the numbers is zero. Next, we have roots, which is just the solutions of a polynomial equation. And our last term to go through is repeated roots, which means two or more roots of an equation that are the same number. So there you have it. Those are the four main things that you need to know as we move forward in this section. You can always pause here if you're at home watching this video or watching this individually so you can get all of this written down, or you can take a screenshot, whatever works best for you. But we are going to flip back up to page 219 to actually work through the notes. So we're going to start off with exploration 1, matching equivalent forms of an equation. So we have three options here. We have a factored form, a standard form, and non-standard form. So we've been dealing a lot with the standard form. We've been looking for the highest exponent and putting it in order from biggest exponent to smallest exponent. That is what standard form is. That's nothing new. Non-standard form is just like what you would do or what it would look like before you get it into standard form. Maybe it's not put in the right order. Maybe you've got something other than zero on the right side of the equal sign, but it can all be manipulated to look like standard form. Then there's factored form. So if you guys remember doing the X game, this is where the X game truly comes into play. So where you have the two numbers that multiply to one number and then add to another number, that's where we're going to get with this. So we're going to have to do a couple different things as we work through these. So starting off with this first one, we have A. So what I think is going to be easiest is if we go through and multiply all of them out. So practicing what we've been working on this last week and really putting it into play. So we're going to start with A. We're going to multiply everything out. So we're going to take x times x, which gives us x squared. Next, we're going to take x times -3, which gives us -3x. -1 times x, which gives us -1x, or just -x. And then lastly, -1 times a -3, which gives us a +3. So right away, the only two things that we can combine together on this one is going to be our -3x and our -1x. By doing so, we're going to get x squared minus 4x plus 3 equals 0. So again, we're just using what we did last week and applying it to this. So x times x gives me x squared. X times -3 gives me a -3x. -2 times x, -2x. And lastly, -2 times -3 gives me -6. Again, the same two pieces can be combined together right here. So we end up with x squared minus 5x minus 6 equals 0. So go ahead, pause here, see if you can multiply out C, D, and E. So if you're just joining back, we have completely gone through and multiplied everything out in order to get it into standard form. So now this is the easy part. Going from factored form to standard form, we just take what we have already multiplied out and match it to the letters in the standard form section. So I'm looking for x squared minus 4x plus 3, which would be capital C. Next, I'm looking for x squared minus 5x minus 6, which is capital D. Next, x squared minus x minus 2, which is capital B. Next, x squared minus x minus 2, which is capital A. And then that means the last one, x squared minus 2x minus 3, goes with letter E. So as we move on to the non-standard form, this section isn't going to be nearly as difficult or take as much work. Some of it's just going to take simply moving what's on the right side of the equal sign over to the left, because for standard form, it has to be equal to 0. So let's go ahead and look at that. So on this first one, in order to get a -6 to become 0, I have to add 6. Whatever I do to one side, I do to the other, and I get x squared minus 5x plus 6 equals 0. And so I'm going to start with all the easy ones, and then I'm going to work my way back. So next, I'm going to do number 3. So I have x squared minus x equals 2. In order to get 2 equal to 0, I subtract 2 from both sides. I get x squared minus x minus 2 equals 0. I'm going to skip down to the last one. In order to get a -3 become positive or become a 0, I add 0, or I add 3 to both sides. So now I get x squared minus 4x minus 3, or sorry, plus 3 equals 0. So now we just have to do 2 and 4. So I'm going to start off with 4. So I'm going to multiply here and here. So we get x squared minus or plus x equals 2. In order to get that 2 to be equal to 0, I subtract 2 from both sides. X squared plus x minus 2 equals 0. And so that's going to allow us to do some process of elimination when we get to number 2. So When I have x squared minus 5x plus 6, that's going to go with letter D. X squared minus x minus 2 goes with letter A. X squared plus x minus 2 is going to go with letter B. And x squared minus 4x plus 3 goes with letter C, which means 2 goes with E. And we didn't even have to do the work on that one. The whole point of this is showing you that it can be written in so many different forms and it's still equal to the same thing. You just have to do a little bit of work in order to get it to that point. So next, we're moving on to exploration 2, writing a conjecture. So what we're going to do is we're going to substitute 1, 2, 3, 4, 5, and 6 in for x in each equation and determine whether the equation is true. We're going to organize our results in the table and then write a conjecture describing what you discovered. So we're going to start off. We're going to plug in 1 for all of the x's. So this would become a 1, and this is a 1. So we have 1 minus 1, which is 0. And then you're going to take 1 minus 2, which gives us a negative 1, which gives us 0. Let's just move on below to the next one. So I have 1 minus 2, 1 minus 3. 1 minus 2 is negative 1. 1 minus 3 is negative 2. And that multiplied together gives me a positive 2. And so go ahead and keep on going. You can always check back here as I'm working through them, or see if you can do this multiplication and subtraction on your own. So if you go back through and look through all the answers and all the work, we're getting all of these numbers. Some are very similar, some are the same, but then you notice the zeros. Whenever you get a zero, that is what is considered a solution. That means we successfully solved that equation. So that means looking at equation A, 1 and 2 are solutions. So 1 and 2 are solutions. Looking at B, our solutions would be 2 and 3. C would be 3 and 4. D, 4 and 5. E, 5 and 6. And F, 1 and 6. Looking at that information, what do you notice about the equation? So, for example, looking at just A, we have x minus 1 and x minus 2. Our solutions are 1 and 2. Whatever the number is here, so that's a -1. We've got the minus sign in front of it. The opposite is the solution, so +1. This would have been x plus 1. Our solution would have been -1. And when it's written like this, so in factored form where you have 2 or more sets of parentheses, that means that's how many solutions you're going to have. So we have 2 different numbers, 2 sets of parentheses, 2 solutions. If they would have been both the same, so x minus 1 times x minus 1, yes, we still have 2 solutions, but we're only going to get one number because only one number will get to 0 from there. So next, we're going to go into some special properties of 0 and 1. These are all things that we have gone over before in math classes and are very important as we move forward. So for the next few questions, the numbers 0 and 1 have special properties. They are shared by no other numbers. For each of the following, decide whether the property is true for 0, 1, both, or neither. So at this point, I want you guys to be answering in the chat if we are doing this through Zoom, or you can put your answer on the page. So it says when you add blank to a number n, you get n. So we're going to just say n, and this one is equal to 3. So we're trying to figure out what number, when we add it to 3, gives us 3. Is it 0, 1, both, or neither? If you said 0, you would be correct because the only way to get 3 to stay the same in addition is to add 0. If the product of two numbers is blank, then at least one of the numbers is 0. So product refers to multiplication. So we have two numbers. So we're going to just say one of the numbers is going to be 2. And I have to figure out what the second number is, and it equals 0. Well, anything times 1, 0, or both of those numbers or neither will give you 0. If you said 0, you are correct because 2 times 0 gives you 0. The square of blank is equal to itself. So let's test it out. What's 0 squared? 0. What's 1 squared? 1. So that means this is both. The next one, when you multiply a number n by blank, you get n. So we're going to say n is equal to 3. So 3 times what number gives you 3? Is it 0, 1, both, or neither? The answer is 1. 3 times 1 gives you 3. When you multiply a number n by blank, you get 0. So 3 times what gives you 0? You said 0, you are correct. The opposite of blank is equal to itself. So the opposite of 0 is just 0. The opposite of 1 is just -1. So obviously it's only true for 0 because 0 really doesn't even have an opposite. So you will work forward into page 222 later on this week when we start solving the equations, and Mr. Patinsky will lead you through that. Make sure you got all your notes written down. We will have a quiz probably next week over all of this, and being able to use your notes is something that you can do. So making sure that you are prepared is what's best. And so with that being said, I hope you all have a wonderful rest of your day. And if you have any questions, reach out to myself or Mr. Patinsky.